In the last video, we examined the basic principles of scientific realism. We saw that scientific realism makes three claims. First, the metaphysical claim that there is an external world, mind-independent world. The semantic claim that scientific theories should be construed literally. So when scientists talk about electrons, for instance, they literally mean these incredibly tiny little particles with a negative charge, and the epistemological claim that our best scientific theories are approximately true. Now, the main debate regarding scientific realism these days concerns the third claim. So should we believe that our scientific theories are approximately true, that unobservable entities such as bacteria, electrons and black holes really exist? Should we believe that? Well, today we're going to look at one of the primary arguments for realism, which is the NoMiracles Argument. Now, in its basic form, this is a very simple and intuitive argument. I think Hilary Putnam put it very nicely when he said, the positive argument for scientific realism is that it is the only philosophy that doesn't make the success of science a miracle. Nobody doubts that science is extremely successful. Part of this is shown in the explosion of technology that we've seen over the past few hundred years. Humans have in many ways conquered nature. We have shaped the world to our will. Just consider life expectancy over time. If you go back to the 1600s, half of all people died before the age of 8. We have conquered these appalling child mortality rates, and a big part of that was the development of science. Another very important element of success is predictive success. Scientific theories make risky predictions, and these predictions are very often shown to be correct. In the last video, I mentioned some of the risky predictions made by Einstein's theory of relativity, gravitational time dilation, gravitational redshifting of light, and the bending of light by large mass. These are all surprising predictions. They're predictions that nobody would have had any reason to make if not for the theory. And so, scientific predictions very often also display a very striking degree of accuracy. I remember reading that the predictive accuracy of certain claims in quantum mechanics is analogous to predicting the length between London and New York to within the width of a human hair. This predictive success is the kind of success that realists tend to focus on. Our best scientific theories are extremely good at telling us what to expect of the behaviour of observable phenomena, and the realist says the best explanation for that is that what those theories say about unobservable phenomena is true. Now, it's important to be clear that successful theories are those that make correct novel predictions. Some theories are constructed so as to fit the phenomena, as it were. Consider Ptolemaic astronomy, which was the dominant model of astronomy before the 1600s and held that the Earth is the centre of the universe. The Ptolemaic system was actually remarkably good at predicting the movements of the planets. But this is because the theory was explicitly constructed by observing how planets moved and then adjusting the theory accordingly so that the predictions of the theory would match the observations. So it's no surprise that Ptolemaic astronomy fits the phenomena, and obviously that doesn't support any claim for its truth. What's striking about modern scientific theories is that they will often predict a phenomenon that we were previously unaware of. They make surprising predictions, and those predictions are often confirmed. So the realist asks, what could explain this success if not for the fact that scientific theories are true? If our best theories were not at least approximately true, the success of science becomes a miracle. It becomes a kind of cosmic coincidence. So that's the basic no miracles argument. One thing that's maybe worth noting in passing is that although the no miracles argument is often framed in terms of success, it seems to me that possibly some of the failures of science might could support the same conclusion. For instance, arguably the best explanation for the increasing failure of antibiotics is that there really are bacteria and they really are developing resistances to antibiotics and so on. Although perhaps that's actually a success of science, because that was that was predicted way back in the 1940s. We've long known that bacteria should develop resistance to antibiotics. So perhaps that would actually count as an example of predictive success, a phenomenon we would otherwise have no reason to expect, but that turned out to be true. So anyway, let's put the NoMiracles argument a bit more formally. I take this from Carl Matheson. Science is extremely successful. Scientific realism provides a better explanation for this success than any other philosophy of science. We should believe the philosophy of science that best explains the facts about science. We should believe scientific realism. Obviously, this argument is an inference to the best explanation, or abduction, and the basic form of inference to the best explanation seems reasonable enough. Here's another example of inference to the best explanation from Bas van Frassen. Suppose you hear scratching in the wall, the patter of feet at midnight, and your cheese disappears. You infer that a mouse has arrived at your house. There are many other possible explanations, but this is the best one. And notably, of course, you infer that there really is a mouse in your house. It's not that you think that the theory that there is a mouse in your house is instrumentally useful or anything like that. No, there really is a mouse in your house. And notice as well, of course, that this kind of inference is used extensively in science. So the scientific realist would say that all we're doing is applying the methods of science to science itself. We have a certain puzzling fact about the world, namely the success of science, the surprising predictive success of science, and we claim that the best explanation for that success is that mature scientific theories are approximately true. So we should believe that mature scientific theories are approximately true. I think that's a fairly intuitive argument. It seems kind of an obvious argument in many ways, nice simple argument there, but there are a number of worries about it. So an immediate question is whether realism does best explain all the facts. The NoMiracles argument is framed in terms of the success of science. But notice that even if realism best explains success, it may run into trouble with other facts about science, such as theory change, for instance. Now, the problem of theory change is a very important argument against realism. We noted it in the last video, and I will examine it in more detail in a later video. It deserves its own video because it's a big argument. So for now, I want to put this to one side and just focus on the success. So is realism the best explanation for the success of science? And if it is the best explanation, is that a good reason to be a realist? So the second problem here is the worry that this argument, the NoMiracles argument, is circular. The charge is that it seems that this use of inference to the best explanation assumes realism, so this can't constitute an argument in favour of realism without begging the question. This criticism has been made by Arthur Fine, for instance. Fine points out that if the anti-realist is right, the use of inference to the best explanation can't be assumed to lead to true explanations, at least with respect to unobservables. Let's consider an example from science. Certain galaxies, known as active galaxies, emit an extraordinary amount of energy from a relatively small region in their galactic centres, and these are called active galactic nuclei. The most powerful of these active galactic nuclei are quasars. A quasar is a region in the centre of a galaxy. It's sometimes not much bigger than the size of our solar system, but that has the luminosity perhaps 100 times as great as the entire Milky Way. So this is an extraordinary amount of luminosity. It's incredibly bright. Now, it appears that the best explanation for active galactic nuclei is that the energy is produced by an accretion disk surrounding a supermassive black hole. This model can explain various properties of active galactic nuclei. The extreme luminosity arises because theoretical models suggest that the accretion disk surrounding a black hole can convert about 10 to 40% of the mass energy of matter into thermal energy, and that ultimately is transformed into photons. And this is far more efficient than stars, which operate by nuclear fusion. Nuclear fusion, even in the brightest stars, will convert less than 1% of the mass energy into photons. So this accounts for the extreme luminosity. This model also accounts for a few other properties. For instance, active galactic nuclei shoot out two powerful jets of particles in opposite directions at nearly the speed of light. And that's caused because the accretion disk spins very, very rapidly, and what this does is it creates very tightly twisted magnetic fields that shoot out in two opposite directions, and particles fly out along these magnetic fields. So the point is, many of the properties that we observe in active galactic nuclei are accounted for by assuming that it is an accretion disk surrounding a supermassive black hole. That's the best explanation, but of course the anti-realist will deny that this explanation is true. The explanation may match our observations, and indeed if it's the best explanation, we should accept it. But accepting a theory for the anti-realist doesn't mean believing that the theory is true. Accepting a theory merely means using the theory, or believing that it is empirically adequate, or whatever. Remember, a theory is empirically adequate if what it says about the observable parts of the world is true. So, according to the anti-realist, inference to the best explanation leads to acceptable explanations, or to explanations that are likely to match observable phenomena, or whatever. Insofar as the scientific realist assumes that the best explanation leads to true explanations, he simply begs the question against the anti-realist. But the NoMiracles argument uses inference to the best explanation to infer the truth of scientific theories, and that would seem to be question-begging. So I think what the realist could say here is that we need to pay a bit more attention to the form of the NoMiracles argument. The NoMiracles argument doesn't rest on the assumption that the best explanation is the true one. It only rests on the assumption that we should accept the best explanation. It's just that accepting the best explanation entails truth in this case. So, to be clear, the realist claims that the best explanation for the success of science is that mature scientific theories are approximately true. Now, we don't need to say that this explanation is true, we need only say that we should accept this explanation. Merely accepting this explanation itself entails realism. In other words, the realist doesn't need to say it is true that our best scientific theories are approximately true, but merely we should accept that our best scientific theories are approximately true. In both cases, we get the conclusion that our best scientific theories are approximately true, which is scientific realism. The first formulation is arguably circular, but the second isn't. And then, of course, this is really just semantics, since I think both formulations are pretty much exactly the same conclusion in terms of what we should believe about the nature of scientific knowledge. I'm not so convinced that it is circular, although of course if you totally reject inference to the best explanation, then you obviously still won't accept the NoMiracles argument, even reinterpreting it like this. But I would say that anti-realists generally don't reject inference to the best explanation, they merely reinterpret it. The anti-realist is happy to use inference to the best explanation, provided we say only that we should accept the best explanation, rather than that we should believe in the truth of the best explanation. An inference to the best explanation isn't really avoidable, because if we were to do away with inference to the best explanation, we'd have to do away with huge chunks of modern science. I just want to note here that you may read in the literature that anti-realists reject inference to the best explanation. I think the Stanford Encyclopedia of Philosophy article on constructive empiricism describes how the constructive empiricist rejects inference to the best explanation. But I will stick to my guns on this. From what I've read, what anti-realists reject is the claim that inference to the best explanation leads to true explanations. If we reinterpret inference to the best explanation and hold that it leads to merely acceptable explanations, or merely empirically adequate explanations, or whatever, that's perfectly acceptable to the anti-realist. And again, unless you want to do away with huge chunks of modern science, I don't really see a way of avoiding inference to the best explanation. A third criticism is that, quite simply, realism is not the best explanation of the success of science, because the anti-realist can provide explanations that are just as good. Now, there are really two questions here. First, can the anti-realist provide alternative explanations? And if so, what are the criteria for determining which explanation is the best? Let's consider some possible alternatives. An interesting suggestion made by Bas van Frassen is what he calls the evolutionary explanation, and I quote, "Any scientific theory is born into a life of fierce competition, a jungle red in tooth and claw. Only the successful theories survive, the ones which in fact latched on to the actual regularities in nature." That last part might sound quite realist. Van Frassen is a defender of constructive empiricism, which, you recall from the last video, asserts that we have knowledge of observable phenomena, but not of unobservables. So by actual regularities in nature, he's talking about regularities in observable phenomena. In other words, empirical adequacy. As noted, a theory is empirically adequate if what it says about the observable parts of the world is true. Empirical adequacy and other forms of success can be explained by this evolutionary mechanism of competition, and the way that the way that sciences are structured is that every theory is subjected to ruthless testing and examination to make sure that it comports with observable phenomena. So there's simply no need to postulate truth because we have this evolutionary explanation. Now, I think the main problem with this is that although it tells us how we came to accept some theory T, it doesn't tell us why it is that T is successful. Why, among the many possible theories we could have adopted, is T the one that latches on to observable regularities? Van Frassen simply has no answer here. All he can say is that T does latch on to observable regularities, and so we come to adopt it as a result of the evolutionary competition in science. But the realist has an explanation. The realist says that T is successful because T is approximately true. I mean, another way to put this point would be to consider a question such as, why is germ theory successful, whereas miasma theory isn't? To say, because germ theory is approximately true, whereas miasma theory isn't, well, that's a good explanation. But Van Frassen's answer is, because germ theory was selected by a Darwinian process, whereas miasma theory wasn't. And that is no explanation at all. The question is, why was germ theory selected over miasma theory? That's the crucial question, and that's where the realist appeals to truth. We all agree that science operates as a competitive evolutionary process that picks successful theories, but the question is, what is it that makes those theories the successful ones? So it's not so clear that this explanation works. A second option is suggested by Jarrett Leplin, which he calls surrogate realism, though I call it the as-if explanation. This claims that our best theories are successful because the observable world behaves as if our best scientific theories were true, or approximately true. This explains why science is successful, just as well as the claim that our best scientific theories are approximately true. So the fact to be explained is the success of science, the amazing predictive accuracy of certain theories, say. Now the realist explains this by saying, well, those theories are successful because they are approximately true. The anti-realist says those theories are successful because the observable world behaves as if they were true. We can be agnostic about whether or not they are true. The crucial point here is that both of these explanations have the same empirical consequences. Anything predicted by the realist explanation would equally be predicted by the anti-realist explanation, by the as-if explanation, since they clearly both say the same thing about the behaviour of the observable world. And I suppose one way to put this explanation is to say that empirical adequacy is in itself an explanation for success. Now, why is science so successful? Because our best theories are empirically adequate. In other words, because what our best theories claim about the behaviours of observables is approximately true. But we don't need to assume that they are true about unobservables. Again, the basic problem with this is that it seems like no explanation at all. Surely it's simply circular, right? To say that the world behaves as if some theory were true is basically just to say that the predictions of the theory are accurate. So we're explaining predictive success in terms of predictive success. Our question is, why do our best theories make such successful predictions? The as-if explanation is that the observable world behaves as if those theories were true. But what does that does that claim amount to, if not the claim that the predictions the theories make are accurate? So there seems to be perhaps a circularity here. And even if we can avoid the circularity, it still leaves us with the question, why does the world behave this way? I mean, recall the mouse example, right? Saying the observable world behaves as if there were a mouse in your house, that's not a real explanation. The reason why the observable world behaves as if there were a mouse in your house is because, of course, there is in fact a mouse in your house. Similarly, what explains why the observable world behaves as if our best theories were true is that, some other theory which yields predictions very much like our current best theories is true. In other words, our best theories are approximately true. So it's not clear that these two explanations actually work, although there are ways of responding to that point and developing them. But at least prima facie, they have some problems. Now, we can debate whether these are really proper explanations. But now let's turn to our second question, which is, assuming that the anti-realists can provide alternative explanations for the success of science, what are the criteria by which we determine which explanation is the best? In other words, what are the explanatory virtues? I'm going to take 4 suggestions from Moti Mizrahi. There are many other possible explanatory virtues, but I think these 4 will allow us to make the point. So Moti Mizrahi suggests that there are 4 explanatory virtues. Testability, which tells us to choose the explanation that yields independently testable predictions. Unification, which tells us to choose the explanation that best explains the most phenomena. Coherence, choose the explanation that is consistent with background knowledge and practices. And simplicity. So this is choose the explanation that posits fewer types of entities, fewer types of properties, the explanation that is least complicated, and so on. I mean, that's basically Occam's razor. Do not multiply entities beyond necessity. Be simple and elegant. So how does realism stack up? Well, let's first testability. Do either realism or anti-realism yield testable predictions? Well, the realist claims that realism predicts the success of science, but of course that fact is used in the construction of realism, so it's not really an independent prediction. And of course, Van Frassen's evolutionary explanation and Leplin's as-if explanation also predict the success of science. If realism is superior to anti-realism with respect to testability, at minimum, we need to show that realism entails some proposition that anti-realism doesn't, and then we need to show that that proposition obtains. But I'm not really sure what that proposition would be. As far as testability goes, all explanations would appear to me to be on a par. With respect to unification, so choose the best theory that explains the most phenomena. Again, realism and anti-realism seem to be on a par. They both explain the same fact, namely the success of science, and that they don't really seem to do much more than that. With respect to coherence, I think arguably realism seems to be the most consistent with how scientists actually talk about science. If you read science textbooks or science articles or reports of scientific discoveries, there does seem to be an assumption of realism. Let me give you just one example. In the textbook The Cosmic Perspective, Stars, Galaxies and Cosmology, which is a textbook for astronomy, there's a section on page 641, literally titled, Do Supermassive Black Holes Really Exist? I mentioned supermassive black holes earlier. There's a bit in this astronomy textbook that the title of the section is literally, Do Supermassive Black Holes Really Exist? And the writers think that supermassive black holes do really exist, and they regard it as sufficient to simply list the standard evidence for supermassive black holes. For instance, measurements of the orbital speed of gas near the centre of the galaxy M87 shows that the gas is orbiting an object about 2 to 3 billion times the mass of the Sun. Evidence such as this is assumed to demonstrate the existence, the reality of black holes. So, there seems to be an assumption of realism in science, so perhaps realism wins on coherence. For simplicity, well, it actually looks like anti-realism wins there. The anti-realist obviously postulates far fewer entities than the realist. Although notice, of course, that with simplicity, outright skepticism would I suppose, be the best here. Outright skepticism doesn't postulate anything beyond immediate sense impressions. So, and actually, I suppose some skeptics could even be skeptical of that. So, but anyway, anti-realism appears to win on simplicity. Anyway, the point of all this is that it's not clear that realism actually provides a superior explanation when we consider all of the explanatory virtues. So I think that what the realist has to argue is not that realism is the best explanation for the success of science, but that it's the only explanation. And we've seen that a major criticism of the evolutionary explanation and the as-if explanation is that they're not really explanations at all. They're simply circular or whatever. And I think that's the way the realist is going to have to argue here, because if the anti-realist does have an explanation, if it turns out that the as-if explanation is a proper explanation, then I think that at least on these explanatory virtues, anti-realism and realism are going to be at least on a par, and maybe anti-realism is going to come out ahead. So the realist, as I say, will, I think, need to argue that the anti-realist simply has no explanation at all, and realism is the only explanation. And of course, that's a somewhat more difficult argument to make. Okay. A fourth objection. We saw in response to the claim that the anti-realist can provide alternative explanations for the success of science, the realist will respond that these so-called explanations are not really explanations at all. But the anti-realist can equally argue that the realist explanation simply fails. The realist doesn't really have an explanation. So let's be clear, the puzzle here is the success of science. Why is science so successful? The realist says it's because our best theories are approximately true. Now, we must assert only approximate truth because there's obviously very good reason to expect that science will continue to develop and change in the future. The theories we accept now will be altered, perhaps significantly, in the future. But now the anti-realist can ask, well, why expect that approximately true theories will be successful? I mean, obviously a true theory will be successful, but why should a merely approximately true theory be successful? I mean, consider physics. Take the standard model of particle physics, and let's suppose it's totally true. Here is a chart of the entities postulated by the standard model. Now, let's say we construct a new theory, and we construct this theory by simply removing the electrons from the standard model. In some sense, this theory is approximately true. I mean, surely it is. If we're assuming that the standard model is the truth, then this theory is, in a sense, approximately true. It's pretty much right about the basic constituents of reality. It's just slightly incomplete. But it would be totally hopeless as a scientific theory. It would just run into all sorts of serious problems and setbacks. I mean, it's probably not even logically consistent. We need electrons for this theory to work. But that means that approximately true theories can be completely unsuccessful. And that means that approximate truth isn't really an explanation for success. It must be some other feature that makes theories successful. Now, the realist might respond here that although approximate truth may not be sufficient for success, it is necessary for success. In other words, not every approximately true theory will be successful, as the standard model example shows, but every successful theory will be approximately true. It must also have other features, but approximate truth is necessarily one of those features. However, this surely can't be right, because it is, presumably it's at least possible that great success could be had by a theory that isn't approximately true. I mean, that might be very unlikely, but it's surely possible. So, at best, what we can say is that approximate truth increases the probability that a theory will be successful. Consider another explanation of this sort. For instance, we might explain the fact that John has lung cancer by appealing to the fact that John smoked. The point is that smoking increases the chances of lung cancer. Some people with lung cancer never smoked, and some smokers never get lung cancer. But if you do smoke, your chances of lung cancer rise. Presumably then the realist claim is that approximate truth raises the chances of success. So how do we justify this claim? I mean, it's easy enough to justify the claim that smoking raises the chance of lung cancer. Essentially what we do is we simply look at rates of lung cancer in the general population, look at rates of lung cancer among smokers. If we find that rates of lung cancer among smokers are higher, that establishes a correlation. We then need to do some further tests to rule out coincidence and third factors and so on. But this first step is particularly important. So similarly then, for the realist claim that approximate truth raises the chance of success, presumably what we first need to do is look at rates of success among theories in general, and then rates of success among approximately true theories. And the problem is, how on earth are we supposed to do that? There's just no possible way to come up with such a list, and more importantly, notice that even if we were able to make such a list, it would beg the question in favour of realism, because it would assume that we can determine when theories are and aren't approximately true, and obviously that pretty much assumes that anti-realism is false. So even in principle, it looks like there's no way for the realist to build his list, and that means the NoMiracles argument can't get off the ground. Okay, a fifth objection, perhaps somewhat similar to the last one, is that the NoMiracles argument commits a common probabilistic fallacy, the base rate fallacy. This objection has been made by P.D. Magnus and Craig Callender. So what's the base rate fallacy? Well, here's a famous illustration. Consider a disease and a test for that disease. Suppose the rate of false negative results in the test is 0. So if the disease is present in an individual, it is detected 100% of the time. The rate of false positives is 5%. So for every 100 people who don't have the disease, 5 of them will nevertheless test positive for it. Now, suppose John tests positive for the disease. What is the probability that he has the disease? Well, looking at the raw numbers, a lot of people assume the probability is 95% because they think, well, false positives are 5 out of 100, 5%, so 95 in 100 must be correct. So if they've got a positive result, that looks like 95% chance of having the disease. But that's completely wrong, and this is an instance of the base rate fallacy. In order to calculate the probability that John has the disease, we need to know not just the test result, but also the base rate of the disease in the population. What proportion of the population have the disease? Suppose that the disease is rare, only about 1 in 1,000 people have it. Given the assumption that the rate of false positives is 5%, this means that 50 out of 1,000 people will test positive even though they don't have the disease. In other words, given these assumptions, we can expect 51 people to test positive, and yet only 1 of those 50 will actually have the disease. The chance that a random person from the population who tests positive has the disease is therefore only 1 in 51, or 0.5%, not 95%. As another example to illustrate the point, suppose that nobody in the population has the disease. Suppose it's a test for Ebola. Here in the UK, nobody has Ebola, although after recent events, I'm quite sure we could convince the population to vote for Ebola as well, just tell them it's sovereign, independent British Ebola. Anyway, we don't have Ebola here at the moment. If the rate of false positives is 5%, we can expect many people who are tested to test positive, but the chance of them actually having Ebola is pretty much 0. Magnus and Callender argue that the NoMiracles argument is really a probabilistic argument, which commits this fallacy. So the form is like this. Theory T is successful. True theories are very likely to be successful. False theories are not likely to be successful. So there's a high probability that T is true. But what's the base rate of approximately true theories? We can only conclude that a successful theory is likely to be true if we know this base rate. The no-miracles argument has essentially the same form as the fallacious disease argument. So the disease argument would be, John has tested positive. People with the disease will test positive because there are no false negatives. The disease is caught 100% of the time. People who don't have the disease are unlikely to test positive. The rate of false positives is only 5%. So there is a high probability that John has the disease. As we saw, that's a fallacy. And the no-miracles argument has the same form as the fallacy. The no-miracles argument commits a straightforward probabilistic fallacy. How might the scientific realist respond? Well, one response suggested by John Worrell is that probabilistic arguments don't really capture the form of the no-miracles argument. So Magnus and Callender are wrong about the form of the argument. The argument, as we saw, is an inference to the best explanation. So really, Worrell suggests, the argument has the following form. The argument claims that there are really only two plausible explanations for the predictive success of some theory T. Either T is approximately true, or T just happens to latch on to observable regularities by chance, despite being radically false. Now, one is obviously a superior explanation, so we should accept it. Now, that's the argument, that's it. And this argument makes no claims about probabilities. We're simply claiming that approximate truth is a better explanation for success than the alternative. I'm not really sure this response works. I mean, surely the anti-realist would object that the only reason to believe that approximate truth is a better explanation than mere chance is because of the assumption that approximate truth raises the probability of success. And if approximate truth doesn't raise the probability of success, then why on earth would it be a better explanation? So Worrell's formulation doesn't really remove the fact that the no-miracles argument depends on a probability claim, it just disguises it. Okay, a second response is from Leah Henderson. Henderson asks, well, how do we determine the base rate? It's true that if we consider the population of all theories, the base rate of approximately true theories must be extremely low. It must be infinitesimally low, since there are an infinite number of false theories. But it's not clear that we should be considering all theories. So regarding the disease case, we assumed in our example that the individuals who were tested were drawn randomly from the population. But suppose instead that the test was given only to people who had been sent to have the test by a doctor after they presented symptoms of the disease. Well, then the base rate of the disease would be much higher, and it may now be perfectly appropriate to conclude that a positive result shows the person to have the disease. Consider, for instance, a test for melanoma, a type of skin cancer. A positive result from a skin sample drawn completely randomly from the population would, that wouldn't indicate any disease. But if the skin sample was drawn from a large mole that has undergone various changes recently, well, that would strongly suggest that cancer is present. Henderson suggests that, similarly, we should not consider the base rate of true theories in the general population of theories that happen to fit the data. The scientific method selects from this population a very, very small sample, and this sample was not drawn randomly. The significant success of scientific theories is sufficient to show this, so the great success of certain theories may be sufficient to demonstrate their truth. A second point raised by Henderson is that there are really two types of no-miracles argument. There are local and global versions. A local no-miracles argument looks at a specific theory. We might say for some specific theory T that T is highly successful, and the best explanation for this success is that T is approximately true. This is how Magnus and Callender frame the no-miracles argument. But the global no-miracles argument considers science as a whole. It says science is successful, and then it infers that the best theories of science are approximately true, because that's the best explanation for the success. And Henderson points out that the global no-miracles argument is really an argument about the sampling process of science. The success of science is explained by claiming that science picks out theories not at random, but is biased towards theories that are approximately true. So while the local argument taken in itself might be thought to commit the base rate fallacy, The question of a base rate simply doesn't arise for the global argument. The global argument is a hypothesis, basically a hypothesis about the base rate. It claims that the base rate of true theories, of those theories accepted in the mature sciences, is high. It's not a probabilistic argument, so it commits no fallacy. I mean, think about it this way, because I'm not sure if that was clear. So consider a local disease argument, right? The argument is John has received a positive result on the test, therefore it's likely that John has the disease. This commits the base rate fallacy, as we saw. But now consider the following argument. Suppose that several thousand people have taken the test, and 9 out of 10 of them receive a positive result. Well, in that case, it would be quite reasonable to say most people receive a positive result on the test, and the best explanation for that is that most of them have the disease. We would assume that rather than being drawn from the general population, there's some sort of sampling process at play before they take the test. This is a global disease argument, and no fallacy is committed here. Furthermore, notice that if John is one of those several thousand people who had been previously selected by the sampling process, then the local argument no longer commits the base rate fallacy. In the case of the local argument, if we know that if we know that from the global argument that the base rate of disease is high, then it's perfectly reasonable to infer that John has the disease. Similarly, the global NoMiracles argument claims that scientific theories in general, or at least scientific theories that are widely accepted in the mature sciences, the global argument claims that these are highly successful, and this is explained by the fact that most of these theories are approximately true. These theories were not drawn from the population of theories at random. Science is an extremely strict selection process. And furthermore, given this global no-miracles argument, this allows us to say of some particular successful theory that this theory is probably approximately true as well. So I mean, I hope that was clear. When you try to think about probability, it's can be quite difficult. I find, but I hope that was reasonably clear. If we distinguish local and global forms of the argument, we can run the no-miracles argument in a way that avoids the base rate fallacy by taking it as a global claim about scientific theories in general. So that's all I wanted to talk about today. Obviously, there's a lot more to be said about this argument, but I think that's probably enough for an introduction to it. Hope you found that helpful. In the next video, we will look at some anti-realist arguments. But that NoMiracles argument is probably the most famous argument for realism. Not the only one, but it is I think the biggest. And I do find it, it's a fairly intuitive argument, but as we've seen, it has some pretty serious problems. So that's all for now. Goodbye.